I am Laur Kanger from the University of Tartu, Estonia. And, for the past, I think, almost 8 years now, I've been working on a topic called deep transitions. So trying to make sense how to understand modernization through co-evolving socio-technical systems. And in particular, I'm now leading two projects which focus on the industrial modernity part of the deep transitions framework. So the really macro level beliefs and norms and practices that are related to the natural environment, science and technology. And for the past 9 months, we have been working towards a very rough sketch of a theory. And today I'm going to tell you a little bit about what we found. And this will be probably a somewhat longer talk than 20 minutes because there is a lot to go through. So I'd rather get started. All right. So let's start with what's going on in the kind of wider ecosystem of academic literature. So you're probably well versed with innovation and transition studies, and you have probably noticed that a lot of work focuses on micro level or in transitions on the meso level, than the system level transitions. And there is a relative lack of attention to really macro level factors or studies of the landscape in transition studies. There are a few exceptions, of course, but usually landscape is still treated as a residual category. And then you have another strand of literature which is all about the macro level, the sociology of modernity. And if you focus on how these massive guys like Anthony Giddens or Niklas Luhmann, how they analyze things, then they kind of focus on societal change as a whole, but the macro level factors related to science and technology are often kind of glossed over or treated as some causes that interact with other ones. Of course, there are a few exceptions. If you look into the literature, use Mumford, Benninger, and then Arthur's piece on technology all try to analyze really macro-level technoscientific changes. And there is also a huge load of literature on macro-level trends from different fields. So if you look at sustainability science or sociology or economics, you see the diffusion of green patents, the emergence of environmental movements, the socio-metabolic approach to measuring the material footprint of societies and so forth, but it's all over the place and it's massively fragmented. So what we wanted to do in this kind of piece was to develop a conceptual vocabulary for a macro level middle range process theory that focuses on technoscientific factors, macro level factors in their own right as a focal unit of analysis. So not reducing them to something else, going beyond the system level analysis and trying to say something useful on the macro level. And probably doesn't come as a surprise that we took the deep transitions framework as a starting point. And as I said, kind of the formal definition of industrial modernity is the ideas, institutions, and practices related to the natural environment, science, and technology that are pervasive and durable. So when you think about beliefs in progress through science and technology, or regulating the consequences of technological innovation, or the use of fossil fuels as key inputs to economies, then these are the kind of traits that you would find in every industrial society. And 3 years ago, we did a second iteration of these traits, but unfortunately, we have only managed to operationalize a few of them. So this means that we are kind of excluding a lot of substantive important stuff about long-term trends related to industrialization that is well known in historical literature. We mostly haven't kind of placed these traits on the timeline. So this is an ideal typical conceptualization, and we really don't have a good idea when the particular traits emerged. And we kind of assume that once these traits have emerged, at some points they would continue to persist, but we didn't really kind of tried to confirm that in earlier studies. So this study has been an exercise in trying to overcome this limitation. So what did we do? We executed the identification of the traits of industrial modernity in 4 steps. The first, we just started a conceptual analysis. So we had 2 historians and 3 transition scholars in the team, and we took stock of what we knew about the history of industrialization and started modifying the existing list of traits. Then we tried to place each trait on the timeline and justify the placement by finding a quote, usually from a historical a book on history of science and technology, or environmental history, or economic history. Then we tried to document the persistence of each trait over time with a similar approach. So the idea was that, for example, if you have something like some trait, let's say science-based technological innovation emerging during the electrification surge, then we also try to find quotes to document its persistence during the mass production surge and the digitalization surge, so the long wave or great surges of development-based approach. So that means we needed to find around 160 quotes, which took us well over half a year to get it done properly. And then in the end, we also fed the results to a selection of experts, usually historians, who then gave us feedback on what we had missed and where we had perhaps oversimplified approach. And then based on the feedback, we kind of validated another set of traits. So in what follows, I will tell you a little bit about how we kind of expanded on the conventional narrative in the literature. And the conventional narrative, which is very well established, is that science and technology have contributed directly to massive macro level environmental and societal impacts throughout the course of industrialization. So we have had unprecedented rise in societal welfare, very mixed results when it comes to addressing social inequality, and a massive acceleration of environmental degradation. So these things are fairly well known. What we aim to do here was to open up the black box of technoscience and ask, okay, what exactly are the types of ideas, institutions, and practices involved in modern technoscience? And in the following, I'll do a brief recap of history. This will be a lot to take in, so bear that in mind. So what we basically did was we started from the pre-industrial era, because some of the ideas, institutions, and practices that came to characterize industrial societies really emerged earlier, but obtained a new degree of significance later on. So the idea that humans are separate from nature, but still superior, the age of voyages, so going from Europe to Americas, then extracting natural resources and using the results to trade with Asia. Then the idea that scientists should be left to their own devices, which would then ensure that the scientific results would be maximally useful for the society. Then the Mertonian norms. So what is science about? How to conduct it? How should scientists behave? Emerged already before the Industrial Revolution. And of course, the idea that you can commodify ideas, which is a thoroughly Western invention, although its impact on the early industrialization continues to be contested. Now, what happened at the late 18th century was actually a massive explosion when it came to different traits. So it was really a time of massive experimentation. And already from the earliest, the British Industrial Revolution, you start seeing some traits which are very familiar and still with us today. So the idea that nature serves as a resource for human use, then the idea that you have a very selective representation and valuation of nature, then the mathematization of science and codification and formalization of research activities, increasing authority of science compared to tradition and religion, again, these trends initiated from the early Industrial Revolution, but then became amplified later on. For example, by the late 19th century, you had things like Christian Science. So science, Christianity now needed to legitimate itself through a scientific authority. Then, of course, the reliance of fossil fuels and mineral resources, mechanization, use of artifacts, and gradually expanding use of technological artifacts in all areas of life. Belief that, we have unleashed something new. Technology is an autonomous force which inevitably impacts society. Then the idea that labor should be kind of subjugated to the pace of the machine also emerged from that era. And then the growing scale organization and specialization of manufacturing, innovation, and research. Again, a factory was a qualitatively new organizational phenomenon. And of course, many ideas still with us today. So the idea that if technologies create some problems, you can just invent new technologies to fix them. The idea that you can either neglect, redefine, or normalize various risks and harmful impacts of technoscience, kind of keep looking over them if the benefits of using technologies kind of outweigh the harms. And the very modern idea that institutions should actually focus on the impacts of innovation. So scientists and engineers are not held accountable for the invention, which is a very, very modern idea, because in pre-modern times, if you invented a labor-saving machine, you could be seriously sanctioned for this. And then what I would call the first great motor of change, the linking of first technology and later on, 100 years later, science, to economic growth, and then indeed using the profits to further invest in research, development, and innovation activities. So a lot of stuff happened during the early stages. And this continued during the second surge, during the age of steam and railways, where you had, now you first had a party, and now you had people completely drunk. So you could excavate so many natural resources, and then industrial societies really started believing that the supply of resources would be limited and waste would not be a fundamental issue anymore. You had the idea that, when it comes to the governance of nature, the aspirations are superiority, control over nature, and independence from nature. You had the idea that now you can focus on the regulation of societal concerns and kind of downplay the environmental ones, which were gradually surpassed. Then scientists begin seriously believing that they are the bringers of a context-free and self-correcting science. This was accompanied by the increasing professionalization and organization of science itself. Then the idea now that this will continue, a heavy, heavy idea that life will get better and better through the use of science and technology, and the progress will be perpetual. And then the refinement of earlier breakthroughs. So the standardization of technologies, but also the methods of innovation. An increasing recognition that state is really responsible for delivering both advances in science and technology, but also using this for social progress. And finally, we have the second great motor of change, which is using, again, first technology and later science-based industrial power to increase the military capabilities of states, and then again, using the military investments to kind of drive advances in innovations in turn. Right. And now when it comes to the third and fourth wave, these ideas kind of start to be refined. So most of them persist and only a few ones are added. So during the age of electrification, engineering comes of age. So everything that happens here is mostly related to engineering. So the idea that we can solve any societal problem through technological innovation, the idea that technologies are really neutral. So it's the humans that can be erroneous, but technologies are not biased. Then the professionalization of engineering as a separate discipline, key disciplinary norms in engineering. And also, again, the massive self-confidence of Western society. So the idea that from now on, science delivered the authoritative and objective and true knowledge, and other forms of knowledge could now be largely discarded. And of course, the third great motor of change, which was connecting scientific research to engineering, and then the new advances, new technological advances, then prompted new scientific research. And then during the mass production era, of course, we had the great acceleration, so growing generation of waste and the idea that you can throw things away rather than repair them. The kind of expansion of natural science as a role model first to other areas of science, let's say the physics and of economics is a good example, and then in the society as a whole. Then the idea, the scientists came to believe that they were really the main drivers of technological innovation. The quantification of progress, again, when it comes to governance, then the idea that only the things you can measure are actually important. Then the institutional tendency to kind of focus on stimulating the volume and speed of innovation. So the first two frames of innovation, like R&D and systems of innovation, but not so much in terms of directionality. And then, of course, technocratic reasoning and decision-making in policy circles. So you had explicit movements that called themselves technocrats, for example, in the USA in the interwar era, and then de facto technocratic policymaking, for example, in the Soviet Union, in communist China, and later on with the neoliberal turn, also in Europe. So the ideas about new public management and so forth. So that is kind of the entire story over time. And we're only in the very early stages of pulling this together, but kind of three things we can bring out right now. So first off, we definitely noticed that during the first two surges, so the British Industrial Revolution and Age of Steam and Railways, the changes are far more intense and there's so much more novelty. So we have a distinction between the emergence and consolidation of industrial modernity. Then we have the successive emergence of three great motors of change that kind of amplified the impacts of industrial modernity. So the virtuous feedback loops between technology and economy, technology, military, and science and technology. And we also observed that many traits in later surges actually serve to legitimate the kind of tensions between rhetoric and practice that actually characterized a lot of industrialization. For example, it is quite a modern belief to assume that humans are separate from nature. And then you actually observe, the reliance of industrial societies on many resources, far more so than pre-industrial societies. Or the idea that, scientists are objective and scientific knowledge should be prioritized, which was kind of used to delegitimate many types of different local knowledges, even when the local people happen to be right. So, for example, famous cases where people voiced concerns about the impacts of nuclear power plants in certain regions, which were discarded by the scientists. And again, drawing on the societal authority, but not actually on the research itself. So we're still looking into it, but this seems to be a rather troubling find. All right. So that is kind of a massive part of what industrial modernity means. The other part of our framework is, okay, how exactly are these traits important when it comes to broad societal and environmental impacts? And here we introduce the notion of recurrent controversial outcomes. So the idea is that throughout the history of industrialization, science and technology has promised, these fabulous new utopias. But the problem is that each and every time, the kind of traits underpinning industrial modernity or constituting industrial modernity, they generate certain recurrent controversial outcomes which kind of offset the enthusiastic promises. So, this is the way in which we kind of keep repeating the failures and mistakes of industrialization. And right now we have listed 10 of those, so I will only briefly provide the list to you, but most of those would seem familiar to you. So the first one is obviously the socio-metabolic profile of industrial societies, so fossil fuel-based, mineral, and linear. We keep reproducing this. The second one is the division between technocratic elite who knows better and citizens who should listen to the wiser elite. Then we have a critical dependence on highly energy and material intensive socio-technical systems. Well, mobility system is probably one of the best examples of this. Then a spatial separation between the benefits and costs of new technologies. Already in the pre-industrial era, the Americas took the environmental costs and Europeans took the benefits. Then the idea that, if the elite knows better, then any communities that are labeled backward can experience forced industrialization. Then the normal accidents. So individual machine keep getting safer and safer, but overall we have so much complexity in socio-technical systems that accidents also keep increasing. Then the idea that you can have uniform and isolated and highly technologized spaces that are seemingly independent from the natural environment, let's say airports are a good example, is also a pervasive feature of industrial societies. Then another one, of course, the rebound effects that constantly offset gains in technological efficiency. Then the kind of perceived quickening pace of innovation and the acceptance of, let's say, the technological unemployment or constant upgrading of skills, or the general perception that societies keep accelerating and accelerating. And then, of course, postponement of controversial policy decisions on the grounds that more research is needed, or better technologies will be available in the future. Now, the point I'm trying to get at is that these assumptions are very important for current sustainability interventions. And I'll illustrate this using 3 cases, seemingly very different. So solar geoengineering, artificial intelligence, and 100% renewables, all of which have been kind of advertised to provide solutions to the current sustainability crisis. Now, the problem is that if you start reading about these solutions, then you quickly realize that most of the papers rely on very familiar assumptions about science and technology. For example, they kind of assume that technological fix can be found to any societal problem, including massive challenges of climate change. Then the idea is that we should act first and really regulate later. So it's important to act now and act quickly. And of course, the kind of idea that if technology created the problem of climate change, then technology can also fix this. And of course, it doesn't come as a surprise that these assumptions have been heavily criticized. So for example, for solar geoengineering, critics have kind of pointed out that if you apply this, then the impacts will be unevenly distributed and they are difficult to predict. Even furthermore, if solar geoengineering really works and you become to rely on this, then if you have a termination shock and sudden vulnerability and it doesn't work anymore, then you're even more screwed than you were previously. Then for AI, there is a common argument that by the time the negative impacts of AI occur, so if it really works, it might be too late to turn this back. And for 100% renewables, there is almost no consideration of rebound effects. So social metabolic researchers have actually tried to model the kind of material footprint of renewable energy-based infrastructures, and the results are quite discouraging. So it requires really heroic assumptions to say that, you can have a fully renewable energy infrastructure without a considerable increase in the material footprint of industrial societies. So things like this are pretty much overlooked in these accounts. So whenever I need to simplify this, I'm basically saying that, what this slide demonstrates is that people born in the 20th century tried to solve the 21st century problems with the 19th century assumptions. And then they're kind of surprised that it doesn't work. Right. And now it's time to add the third and the final element, which is the feedback of these various broad macro level impacts on industrial modernity itself. And it probably doesn't come as a surprise that as the impacts intensify, they put more pressure on the conventional traits of industrial modernity. And to kind of make the long story short, we can say that we have observed two historical phases in the evolution of industrial modernity. So the first phase, from the late 18th century to the 1960s, was basically about the emergence of two massive themes: treating the environment as a blind spot, and then having massive overconfidence in the capability of science and technology to solve any problem. But with the 1960s, the environmental problems had become so huge that this viewpoint was really not tenable anymore. So from that moment forward, one can talk about the emergence of ecological modernization. So ecological modernization is basically saying that environmental problems are severe, but reliance on conventional approaches to science and technology are enough to solve these problems. And the problem is, of course, that as I just demonstrated, that if we don't change assumptions related to science and technology, then the historical failures from the history of industrialization probably will repeat themselves for sustainability interventions. So that's why we kind of argue that probably, if we're serious about the deep transition, then probably we should also rethink the core ideas about science and technology. And this hasn't really happened yet, or if it has happened, then it has happened in niches. So that's why we are not really in the age of responsible modernization, but we should be if we're serious about tackling the sustainability crisis. So we need to rethink the assumptions about science and technology. And, I leave the most disappointing part for the end, which is, okay, what can we actually do? Well, I don't know. It's just the early stages of the project. I don't have much effort to spend really on developing solutions. But if you look in the history, then you realize that the alternatives have always been there in different niches. So here are a few examples. For example, the prioritization of societal concerns to nature can be kind of countered by seeking a balance between nature and society. And hey-ho, you have a movement which actually discusses providing legal rights to nature. Then you have the ideas about perpetual progress through science, and then lots of studies in science and technology studies showing that the societal context can definitely lead to misuse and abuse of science. And Karl Popper proposed already 50 years ago, even more, that scientists and actually engineers should take an Hippocratic oath. And then, of course, you have, let's say, a belief that technologies are neutral. And again, a lot of STS-informed studies saying that no, design actually reflects user preferences and use preferences. And you have movements like value-sensitive engineering that try to take this into account. So in very general terms, there are kind of three strategies you might entertain. On the ideational level, I'm kind of advocating for the doctrine of technoscientific realism, which is basically a fancy way of saying that we should learn from both about the opportunities of science and technology in history, but also about their limitations. And we should actually develop appropriate safeguards to kind of repeating the same historical mistakes of industrialized societies when it comes to sustainability. Then in the institutional dimension, we probably need some form of a precautionary principle and expansion of this. It had its origins from in alleviating environmental damage. Then it was expanded to single technologies, and now, a few years ago, there was a paper by Johan Markard on unsustainabilities, which argued for extending this to entire technology groups like nanotechnology. But the problem, of course, is that responsibility and acceleration really conflict in their aims. And then we have probably a design and experimentation with transformative niche clusters. And what do I mean by those? I think this tries to find a midway between like optimizing green growth approaches and then grand utopian visions that, eco-anarchism and stuff like this. So total changes in societal order in an indefinite future without any idea how to get there. And kind of the idea behind transformative niche clusters would be to start from specific and readily implementable solutions that challenge particular traits of industrial modernity and then can act as building blocks for broader change. And we had a few years ago, we had a project called DT Futures with the members of the finance sector. And then we actually tried out a few of these niche clusters with the investors. And this is just an example. So here the idea is that you have a dominant trait of simplified and selective valuation of nature. And the alternative idea is to connect individual profit motive to ecosystem restoration. And the niche we considered was basically eco-coin. So the idea was quite simple. Actually, you use automated environmental monitoring, expert-based pricing, an app, and personalized solutions to basically incentivize people to undertake environmental activities, let's say in this case, planting a tree. And depending on where it's needed, you can mine more or less eco-coin, which then you can spend it on the market for ecological goods and services. And then, of course, we had an entire discussion of how this may backfire. And let's say the results were kind of discouraging. But this is basically an example of what we mean by a transformative niche cluster, because it challenges at least one of the very foundational ideas related to the natural environment that is currently dominant in industrial societies. And yeah, I'd actually stop here. And if you're intrigued, then you can get in touch and we'll speak further about this. And I think let's take some questions.